everybody. I just wanted to do a short video on a couple other style examples that we can do with the algebra of functions and with composition. So at the end of one of your homework assignments, I did throw in some questions like this that I really want you to think about. You have all the tools to answer them, but I figured I'd make an extra video just to kind of help you along. So this is one of the questions. And here you have two functions, f and g, and you're asked to find f times g of -1. And what we've been doing so far is we've been always working with the formulas, right? We've had the formulas, we figured it out that way. And I don't have the formula here. So what I want you to remember is that there is another way that you can find this without a formula. And it's using the following idea. So I'm going to kind of go back and forth between my screen shares for a second. So if we're looking for this, yes, what we can do is we can multiply our functions together and then plug in -1 at the end. But in this particular case, I can't do that. I don't have the functions. So what you can do is remember that you can also find f of -1 and g of -1 first separately. And then this is multiplication, right? And now you're going to multiply your answers together. And that works for any operation here, whether you have addition, subtraction, multiplication, or division. You could always individually find those values first. So let me say this works for adding, subtracting, multiplying, and dividing. Individually find those values first and then multiply. Now, remember here that this means that your x value is -1 in each case. So let's go back to the graph. So I'm going to look at the f of x function first, and I need to find out what the value is when x is -1. Well, go ahead and look at that point. So when x is -1, the blue is the f. My f value is at 2. So that first value is just 2. Now for g of x, that's the red one. When x is -1, your g value up here is at 3. So see that point, it's at -1, 3. So g of -1 is just 3. So we're multiplying those two values together, and I get my final answer of 6. So we can do them individually, or we can do it if we have the final function combination. But if we don't, we can go to our graph, or we can go to a table or another tool and just find those values individually, and then either add, subtract, multiply, or divide, depending on the problem. And I want to show you one more like that, but with composition, because that works slightly differently. I'm going to go through. All right, so here's one with composition, and we're asked to find f of g of 1. Now with composition, it's a little bit different. You don't find f of 1 and g of 1 separately together. You actually just need to do it for the inside function first. So when you have a composition like this, and let me show you my writing for a second. What you're going to do is find g of 1 first, or whatever the inside function is. So find this first, okay? So x value is 1 here, and I need to know what the output is for that problem. So let's go back and see. All right, so my g function is the red one, and I have 1. So when we're at 1, it looks like we're down at -2. So g of 1 is equal to -2, right? When x value is 1 on the g function, our point is at -2. So that's how I'm getting that value. And then once I have that, then you're going to take this and plug it into the outside function. Okay. So what happens is f of g of 1 now becomes f of -2, because this right here was -2. So now we're doing f of -2 instead. And again, this is your X value. So I'm going to go back to my graph and find that answer. So here's my F function. My X value is -2. So let's see, there's -1, there's -2. So it looks like we're up at 8. So our final result then would just be 8 overall to answer this question. Okay, so I hope this video helps a little bit because we spent so much time in the lecture really just focusing on equations, looking at the function, looking at the actual algebra of it. But graphically, sometimes it's really helpful too to actually do some examples out graphically and see that there's often more than one way to solve something. So if we don't have the equations, we can still do it. We just have to break it down in a different way.